In this video, we will discuss about the signal and systems and how can we say that the signal is energy signal or the power signal or neither the power signal nor the energy signal. So the definition of the energy signal or the power signal, like a signal is said to be an energy or power signal if and only if its total energy or power is finite. The total energy transmitted to load you can write using these two mathematical equations, like E is equals to integral from minus t to t square of the input signal if the signal is finite duration. But if the signal is of infinite duration, then you can use the limit where time tends to infinity. Similarly, the average power of a signal can be calculated using these two following equations. If the signal is of finite duration, then you will use this formula, but if the signal is of infinite duration, then you can use this mathematical equation. But you need to remember one thing, that energy of power signal is always infinite and the power of energy signal is always equals to 0. For example, we are given a one signal x of t where amplitude is a and the signal changes from 0 to t. So from the graph it shows that the signal is a finite duration signal, and we can write mathematically like x of t is equals to a where t remains bigger than 0 or equals to t. Elsewhere it is 0. So we need to calculate the energy of the signal. As we know that the signal is a finite duration, then we can use this equation E is equals to integral from minus t to t square of the input signal. So if you use the input signal A, so the integral of A square is A square, and you know that the value of the signal is from 0 to t. So everywhere else it is 0. So the integral of 0 is always equals to 0. So you don't need to consider from minus t. So you can consider the limits from 0 to t and the a whole square dt. The answer is a square, because a square is a constant, you can take it out, and the integral of 1 is t. So if you insert the limit, like upper limit is t minus lower limit is 0, so a square multiplied by capital T is equals to a square capital T minus a square multiplied by 0. The answer is 0. So that is why the energy is equals to a square t. For the energy signal, we know that the power is always equals to 0. So how can we calculate the energy or power of a unit step signal? The unit step signal is denoted by using this graph, and we know the equation of the unit step signal ut is equals to 0 if t is less than 0 and is equals to 1 if t is equals to 0 or bigger than 0. So it shows that the signal is of infinite duration. So in order to calculate the energy, you need to use the equation for the infinite durations. So the limits for the infinite duration is from minus t to t and x square dt, but you can change the limit from 0 to t because the signal is 0 from 0 to minus infinity. So that is why you change the limit from 0 to infinity. And from 0 to infinity the signal value is 1, so the square of 1 is again 1, and the integral of 1 is t. So you are just inserting the upper limit and the lower limit. So upper limit is infinity, so that is why the answer is infinity. So energy of unit step signal is equals to 0. Similarly, you can calculate the power of this signal. So the power of signal is written using this equation. P is equals to limit t tends to infinity 1 by 2t from minus t to t square of the input signal, and you can represent that signal by using this graph. So limit t tends to infinity 1 by 2t, and we will consider from the upper limit t and the lower limit 0 rather than minus t, because we don't have any signal from 0 to minus infinity. And the answer is 1 whole square. Again the integral of 1 is t, So 1 by 2t into t, so you can insert the upper limit and lower limit. So the upper limit is t, lower limit is 0. So if you multiply that t with this t, you will end up with 1 by 2. So 1 by 2 minus 0. So 1 by 2 minus 0 is equals to 1 by 2. So the answer is 0.5. So the power of the signal is 0.5.